If we were at the plant pathology farm today, this is what we'd be looking at then. So we've got a 4-acre block or something here. We've got barley on the right-hand side of this field. Then we use Dynagrow 9242, that's on the right-hand side of the wheat, or in between the barley and the rest of the wheat. And then a large block of Ambassador. We use the 9242 as a more partially resistant variety to head scab and other foliar diseases. And we like to use Ambassador because it's pretty susceptible to head scab, so that's helpful for our trials. Obviously, this is all small plot. You can see that from where we've run our herbicide lines through the field to define the plots. This allows us to put a lot of different trials into this area. We obviously don't have time to talk about it all today, but what is in there is generally fungicide efficacy trials. So we have different timings and rates of fungicides, potentially new products that are coming through the lines with different companies, and then some of the head scab integrated trials that we'll talk about this morning as well. And just before we get on to some of that head scab work, we just thought we'd share what we've been seeing this season in our field. So obviously we had that pretty heavy frost or freeze event. And so we were seeing some damage to the leaf tips of our plants out here in East Lansing. And then in terms of diseases, again, our Septoria has turned up. This generally starts most seasons down in the lower part of the canopy. It's really favored by moist conditions, and then starts to move up the canopy. And it's pretty easy to identify in general. On the right-hand side here, you can see the lesions with black fungal fruiting bodies in them, and that's where the more spores are being produced to continue that infection up the plant. And we did have stripe rust turn up. I know the wheat breeders found stripe rust in Mason, just down the road from here. May 25th, and we found it in our plots May 26th here in East Lansing. Given the timing, we weren't overly concerned. If it had been early May, like we saw back in, I think it was 16, then we'd be quite concerned. We would have been, trying to get the word out that people really should be looking at checking their fields, potentially making applications, earlier than heading applications anyway, potentially at the flag leaf. I know we saw back in 16 that the flag leaf applications are absolutely essential at our location here to manage stripe rust because it can blow up so quickly. But again, it was fairly late in May, and so we feel that the applications that are going on at heading will do a good job in managing this disease. And the other thing we do as well is really listen to our neighbours, Wisconsin, Ontario, but also those, and perhaps more importantly to the south of us. What's happening in Indiana, Illinois? Is stripe rust developing there? Is it becoming a concern in Kentucky and other places? If it is, then we'll start to get the word out here that, hey, this thing is coming. We have that sort of surveillance network, which is very, very helpful. And just a note on this too, in terms of identifying diseases, if you're not sure, make use of the MSU plant and pest diagnostic services. There are a number of different things out there that can cause damage to plants, be it viruses, bacteria, or abiotic things. And you don't want to be going out making a fungicide application that's not going to control that particular problem, right? Unnecessarily using resources. So this is also the Michigan Wheat Program pays for sample submission through the MSU plant pest diagnostics. And I think it's also really important for us as a state to know what's going on in terms of what diseases are cropping up and what we need to be dealing with coming into the future. Okay, so I'm going to focus a little bit here on Fusarium head scab because that's really our main issue. So that's caused by the fungus Fusarium graminearum. So that's the same pathogen that causes ear mold in corn as well. And so planting wheat in the corn stubble is not a great idea because corn stubble tends to hang around for a while, and it's a really good residue for that Fusarium pathogen to sporulate on and produce more spores and result in infection. Having said that, we do find Fusarium in soybean roots and dry bean roots. So just because you are rotating doesn't mean you eliminate Fusarium risk altogether. And even if you are doing, excellent rotation work, that's good, but spores can also blow in from outside into your wheat fields. So just some things to be aware of. And as I said before, we do test a lot of different fungicides for management of head scab. And again, I'm just going to focus on one particular trial here for the sake of time. So this is something that we do out at the plant pathology farm here to make sure that we get high levels of head scab. Pretty counterintuitive, I know, for most growers, right? We want to make sure we get disease because we want to screen either varieties or fungicides and fungicide timings for you to make those recommendations. So you can see Michaela here in this video out just spreading grain inoculum that we've colonized with that Fusarium pathogen. And on the left here, that's a photo of the lab that we do that in. So you can see some plates sitting up here on the shelf. So those agar plates will have that Fusarium pathogen sitting on them. We'll take that. We'll actually use bags that are used in mushroom production called spawn bags. We'll fill those with corn grain, autoclave that, and put the fungus in there, the Fusarium, let it grow, colonize that corn grain that you can see here in Michaela's hand. That's got a lot of little black spots on it. That's the fruiting structures of that Fusarium pathogen. Then we spread that in the field. And we do a couple of passes of that inoculum spreading to make sure we get really good pressure for those particular field trials. And then the other thing we do is we try and promote conditions for head scab too. This is a new pivot that we have for this season. And you can see here we're using these lower drop nozzles to try and create a mist across the heads. So again, we're looking at barley here, but the wheat is round to the left. And so what we're doing is basically trying to extend any leaf wetness or wetness on the head, particularly during the night. So we'll run that pivot overnight and put about 1/10 of an inch on just to try and maintain those conditions that are really ideal for head scab infection. So I want to walk you through some data from one of our trials, and I'm going to summarize the bigger picture here in terms of multiple trials and multiple years that we've seen, but I thought it's kind of nice to go through like one specific experiment that we've done. So this is our 2019 head scab trial that was conducted here on campus. So we've got 7 different treatments in this particular example here. So we've got an untreated check, right, where we're not doing anything. We've got Fusarium going on at the 6.5 fluid ounce rate, and that goes up to 8.2, I think, so on the low end of that Fusarium. At flowering at 10.51, so the beginning of flowering. Now, application timing was 7th of June for that year. We've also got Carumba and Miravis Ace. So Miravis Ace is that newer chemistry, just in case you haven't heard of it. So that one's from Syngenta. It's been out for a couple of seasons now. So we're looking at that as well at that 10.51 timing. And then some other things that we're doing as part of this head scab network, which is conducted across multiple states, is looking at 2 applications of fungicide. This might be somewhat cost prohibitive. There's also a treatment in here where we're using a generic. So coming in with some product like Miravis Ace and then coming in with tebuconazole in a generic form. But for these 2 treatments here, number 5 and 6, we're looking at Miravis Ace followed by Fusarium to see what sort of control we might be able to get. So again, that Miravis Ace is going on at that heading timing, but then we're following it up 4 days later with Fusarium for the treatment 5. Or in treatment 6 here, we're going to follow it up with Carumba and see what sort of control we can get. So that's 4 days after that initial application at flowering. And then at the very end here, I've got an application of Miravis Ace that was actually conducted at heading. So just as those heads have emerged at 10.3 prior to flowering, just to see what we would get in terms of disease control. And so that's about 5 days prior to our flowering fungicide timing. So here's data from Ambassador. I've combined 2 different disease parameters that we've taken here. In blue there is the amount of head scab. So that's when we go through and we rate each of those plots for the amount of head scab we'll count 100 different heads or 30 different heads and score them for the amount of head scab that's there. And basically that scale runs from 0 to 100 in terms of disease severity. So 0 would be obviously no disease, and 100 is the maximum amount, right? All heads fully diseased. So obviously you can see in our check here, high levels of head scab, right? We've got about 21 on our disease severity index for head scab. Prosaro, Carumba, Miravis Ace, all significantly lower than that untreated check. So that's good, right? We know we're getting good control from those 3 different products. I will just say, reiterate here that Prosaro was at that lower rate, the 6.5 fluid ounce rate. So it's a little unfair. You know, maybe we could look at increasing that rate and see if we get slightly better efficacy out of that. But that was, Miravis Ace was significantly better than Prosaro in this particular trial. And I want to emphasize this is 1 trial, 1 year. I think it's very, very important for you all to understand. And then a couple of other treatments that we've looked at here. To the right-hand side, Miravis Ace followed by Prosaro 4 days later. We saw potentially, lower amounts of scab there, not always statistically different. And in orange is perhaps more relevant to you, or something that you're more excited about, right? Because that's what really matters at the end of the day, the amount of vomitoxin that's in that grain. Well, one of the more important parameters, of course. So you'll notice that the orange and the blue bar sort of track together, right? So the more head scab that we have here, the more vomitoxin that we get. And I mean, which makes sense, right? When you have more disease, we're gonna pick up more vomitoxin. Out in the field, at different sort of grower situations, I would be very careful about trying to translate that too much, because sometimes we can have very little head scab that are showing in a field, but we take that to the elevator and the DON score can be pretty high, right? So some of it can be hidden. But in this particular trial, we're seeing pretty good correlation between the two. So again, if we look at the orange bars, those Prosaro, Carumba, and Miravis Ace treatments, all significantly reducing the amount of vomitoxin compared to that untreated check. We've still got very high levels, of course, of DON, far more than what we want or what is acceptable. But again, we really are trying to push conditions at this particular location. Where it gets more interesting for me is the double application, so Miravis Ace followed by Prosaro or Carumba 4 days later. That Prosaro, we're able to see a reduction in the amount of DON that was in that grain. So, it points to the message here is that we can potentially reduce the amount of scab and DON by that second application. Obviously, the economics might not always work out, but there's potential there to look at that. And then finally, at the very end here is Miravis Ace. So again, this is at heading, right? So this is before flowering. And of course, we do, in this particular trial, see a significant reduction compared to the untreated check, okay? And you'll look at this and you go, yeah, numerically, that's also lower than some of the, well, I guess it's not than the Miravis Ace at flowering from some of the other treatment. Anyway, let me back up again. So it looks pretty promising, right? This Miravis Ace at heading. I would be very, very reluctant to recommend a Miravis Ace application at heading. Yes, it worked in this particular trial. It did reduce, obviously, compared to the untreated check. However, when we look at more data sets, that heading timing is just nowhere near as consistent as those timings during flowering. So again, we really stress that this fungicide applications for head scab control should be made during flowering. And then this is our 9242 variety, so more resistant to head scab. Again, so very similar sorts of data. We do see a reduction in the amount of disease just by the variety component alone. And then of course with those fungicides, a reduction again, just like we saw in that ambassador variety. So let me just summarize. So this is not just looking at that one trial that I showed you, but in general across many different trials over many years. So what we're seeing then is miravis is just as effective as Carumba or Fusarium at anthesis, which is excellent. The Carumba Fusarium chemistries rely on a mode of action, a DMI chemistry. Miravis has both a DMI and an SDHI, so two different modes of action. So that's great in terms of potentially managing for resistance to fungicides. Michaela has done a lot of work in the lab, and so far we haven't detected strong levels of fungicide resistance to any of the DMI, the Carumba Fusarium, or that SDHI component. So that's really good to know. And just to emphasize again, those early applications of miravis at heading tend to be less consistent. So again, we really recommend that you put those fungicides on to manage head scab at flowering. And interestingly, those two past programs of miravis followed by Fusarium, Carumba, or follow cure 4 to 6 days post-flowering or post beginning of flowering were actually able to reduce the amount of head scab and vomitoxin. And importantly here as well, combining head scab variety resistance and fungicide applications results in lower scab end-on than either approach alone. So it's about integrating disease management, using the most resistant variety that you could find and fungicides at the correct timing to really try and reduce the amount of scab and vomitoxin that we see in our grain. This is a nice slide that Martin Nagelkirk put together just in terms of from days of heading to flowering, in terms of just trying to think through when we need to be making these applications. So day 0, when we're headed, we're about 4 days post that heading that we start to see flowering, right? And in terms of, again, in terms of the fungicide application, we really want to see fungicide application going on either at the beginning of flowering here, which would be in this example, the 4 days post heading, or through to about 6 days post that beginning of flowering, right? And let's just talk about what we mean by flowering, because I think this is a very important thing to clarify. So in terms of when we're looking at a wheat head, flowering starts in the middle of the head, right? And then moves to the top and then the bottom of that particular head. When we say the beginning of flowering, we mean that 50% or more of the heads in that field have flowers on them. That's our threshold to know that we're at flowering, right? And so from the research that we've done, we've shown that optimal head scab can occur from that beginning of flowering when we've got 50% or more of heads with flowers on them through to 6 days post that beginning of flowering, with potentially an optimal 2 to 4 days from that beginning of flowering. There's sort of like a slight sort of sweet spot there when you know more of the plants are flowering. So that's really critical in sort of in terms of timing. Prior to this as well, we really thought that we had to be right out there at the very, very beginning of flowering at that 10-5-1. We were right at that 50% flowering. We know that not to be the case anymore, and you've got that sort of 6-day window where you can get very good head scab control. You go outside of that window more than 6 days from the beginning of flowering, and now you're really going to start to lose control, right? Because we really need to be trying to protect those flowers or the flowering wheat from infection. That's when it's most vulnerable. So I mentioned variety resistance is really important. Of course, you've got your company seed guides to guide you through that, and then the MSU wheat breeders or wheat variety trial folk put these charts together as well, and you can go to their website here to have a look at variety resistance. So an important resource. The other thing I thought I'd show you as well, just the opportunity to give you a live demo, is the head scab risk prediction tool, okay? So this is it, the live website there, and you can see Michigan in here. I'll zoom in a bit, right? And we can look at both today, what is our risk of head scab, and you'll notice that we're in the green, right, which is good. You can see up in the right-hand corner here, we've got a low risk, yellow is medium risk, and red is very high risk, right? If we jump back about 8-9 days here, you'll see that we had very, very high risk, right? And you probably know why. It was cool and wet, right? So those cool and wet conditions are very, very favorable for head scab. We jump back to today, and of course we've had a lot of warmer weather, and so that's really reduced the amount of head scab risk. So that model runs on temperature and also moisture components to give you a prediction of risk today. And so you want to look at this model certainly when we're flowering. If you're not flowering, it's not as relevant, but when we're flowering, that's a very helpful tool to know how important those fungicide applications are. So if you're on the fence whether you should spray or not, it's a tool that could be used to help you with that decision. And remember, it is just a model, but surprisingly, it's quite accurate. And in the handout that you have today available to download, you have a fungicide efficacy sheet, right? And in that fungicide efficacy sheet, we run through all of the different chemistries that are available to you and then give you ratings for those different chemistries. I've highlighted here the head scab efficacy ratings because that's perhaps the most important for what we're talking about right now. So you got Carumba, Miravis Ace, Proline, Fusarium, all rank as good, right? So they're all quite good chemistries, similar efficacy. Then we've got something like the tebuconazole that's sold under various genetics. We typically give those a fair rating. So they're not as good as those other 4 products that I just mentioned, but they have fair efficacy for control, and they are somewhat or often cheaper, so something else to consider. But if you look at your handout, you'll have a whole list of different diseases and a whole list of different chemistries. So if you're trying to manage stripe rust, for example, it's got all those different chemistries and how they rank. And that's not just MSU. We have input into that, but we collaborate with our other neighbors in other states to come up with that ranking. So just to summarize then, integrated head scab management, the first thing you need to do going into next season anyway is to pick your most resistant variety that's available. The fungicide app from flowering to 6 days post-flowering, that's your ideal window for control. And then rotation, of course, you want to avoid planting into corn and wheat residue. And then we want to try and manage for uniformity as much as possible because it's going to be difficult to time a fungicide when fields are very uneven in maturity. And I know people talk about spraying potentially the outside at a different time to the rest of the field, and so that's certainly an option. But if we can get more uniformity in the field in terms of the flowering window, then you've got a better chance of trying to maximize your fungicide to control that disease. And so that's what I've got, and I'd be happy to take any questions, or if Michaela or Martin Nagelkirk want to jump in, I'd be happy to.
We're getting short on time here, so okay. We got a poll up. You had a question earlier about a 8-ounce rates of Fusarium versus the standard 6.5. Can you answer? Have you tried that?
We have. I'm sure we would have. I don't have the data right in front of me, but I would place a bet that higher rate is typically going to give us a better control. I just don't have the data right in front of me to show you how good that would be, but I think they would pull it up to being equivalent to those other chemistries we were just looking at.
Yeah, a little bit stronger also, Marty, in leaf disease. So yeah, there is been that a number of years. Yeah.
Right, thanks, Martin. Yeah.
And we have another one. Was Fusarium followed by Carumba or vice versa compared to the Miravis Ace combination?
Right. So in this particular trial, what we did is just use Miravis Ace at flowering and then followed it by Fusarium, or in a different treatment, we followed Miravis Ace by the Carumba. I am sure, though, given the similar sort of efficacy that we see between Miravis Ace, Fusarium, and Carumba, we could switch these around. We could potentially come in with Fusarium first, follow it with Miravis Ace, or Fusarium, Carumba. I think we could switch those around.
Marty, you have just one more question. Can you comment on why Stratego is not in the table? Is it because DON levels with the strobilurins?
Right. Yeah, that's a good thing to bring up. And I didn't put a slide in about that today. So they're not labeled for head scab application timing window, right? Anything with a strobe in it is not allowed to be sprayed during flowering, and you don't want to be doing that because that strobilurin component of the fungicide can actually increase the amount of vomitoxin that you get in your grain. So they're great fungicides for managing leaf diseases. So applying to flag leaf for stripe rust, absolutely go for it, fantastic. But don't put them on at heading, and the label, you know, you're not supposed to put them on by label anyway.
All right, thank you, Martin and Marty and Dennis, for taking those questions. Hopefully we can get this poll results up because there we are right now. If you want to comment on that.
Sure. One thing I'll just say really quickly. So no one's putting on a T1 with the herbicide. That's interesting. So in some conversations we have, quite a few people are putting it in at that T1 timing, right? Because they're like, well, it's cheap. We're going across the field anyway. Sure. But we sort of wonder about the benefit. And I mean, Martin Nagelkirk's done some studies, and we've done studies too. We tend to see a pretty minimal yield benefit to that T1 timing. And putting it in as an insurance doesn't really seem like a very good idea to me. So the problem is that the fungicide efficacy is going to last for around about 2 weeks or so. And then beyond that, disease is going to start kicking in again, right? So yes, you could certainly, you know, for some reason we have a very, very severe amount of disease very early in the season. Yeah, a T1 application might be very helpful. But I think more often than not, it's not typically going to result in such a yield bump. I think when we do get epidemics of something like stripe rust, we need to be ready to go with a flag leaf application at T2. This year we were fortunate with stripe rust, and I think most of those T3 flowering applications we're going to catch most of that stripe rust pressure and get that under pretty good control.
All right, well, thank you. We need to be moving on here, so really appreciate your work and your presentation.
Thank you.
So.